All right, so we're having a test over Pythagorean Theorem and radicals. If you hear noise in the background, it is what it is. But we have a 10-question review here, and we have a 10-question test tomorrow, Tuesday. So if you can do this review, you'll be able to do that quiz. Now remember, the Pythagorean Theorem, okay, is a squared plus b squared equals c squared. Okay, so on number one, we want to label A, B, and C. So if you have a right angle, A and B are next to the right angle. Across from the right angle is C. So when we set this up, it's going to be 2 squared plus x squared equals 14 squared. Okay, so you actually have to set up with A and B squared. In this case, we're missing B, we're missing a leg. So make sure x is not on the side by itself. Okay, it's on the leg side. Let's square these. 2 squared is 2 times 2. We get 4. Now, x plus x squared equals now 14 squared. If you don't know, okay, calculate your friend. Go in here and type 14, squared button next to it, 196. Okay. Now, when you're solving for x, when you have a missing leg, you need to subtract after you've squared. Okay. So I get x squared equals 192. And my last step to get rid of a square is to square root both sides. Now, square root of 192. Let's do that. It's even, so it's 2 times, and when I find half of 192, I get 96, I believe. Yeah, and then 96 is even, so 2 times 48. 48 is even. 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And then 6 is 2 times 3. I barely made it. Oh, ran out of room there. Okay, that's a lot of pairs. So pair of 2, pair of 2, pair of 2. 3 pairs of 2. So remember, when you're writing your answer, the circled pairs go out to the left. 2 times 2 times 2. It's not 6. You're not adding. You multiply. 2 times 2 is 4. 4 times 2 is 8. The leftover loner is 3. 8 squared of 3. And the reason why I do the factor tree is it says to put it in simplified radical form. That's when you do the factor tree, okay? Very important. So again, number 1, 8 squared of 3, that's good. Number 2, same idea. Here's a right angle, so label A and B next to it. Doesn't matter which one's A or B, as long as they're next to the right angle. Across from the right angle is C, very important. All right, so let's set this up. 8 squared plus b squared equals c squared. So 4 squared plus 9 squared equals c, which is x squared. Square your numbers. 4 squared, 4 times 4 is 16. 9 squared, 9 times 9 is 81. And then add them up. 16 plus 81 is 97. Okay. Now, 97. When you try to break that down, because to get rid of a square is a square root, when I try to factor tree this, I'm going to run into trouble. I cannot find a factor of 97. Okay, you can try all the prime numbers you want, but since there's none, then it's just going to be square root of 97. Okay, so remember, if you can't break it down, just rewrite it. Or if you do break it down and there's no pairs, you just rewrite it. Okay, you can only change it and break it down if you have pairs in your factor tree. Now, the factor tree is only for simplified radical form. This is very important on number 3 and 4. Both 3 and 4, okay, have to do with finding it to the nearest tenth, okay? This is, and it should have said it in the instructions, but this is finding it as a decimal. Decimal. I'm telling you, when you take your test tomorrow, okay, decimal for number 3 and 4, okay? Now, it says a pool floaty measures 8 foot long, okay? So here's my floaty. this is my length, okay, and it's 8 feet long. Then it tells me the diagonal. Diagonal is 9.2. Now remember, diagonals from corner to the furthest opposite corner. This is 9.2 feet. Okay, so that means I'm missing this right here, which would be the width. Okay, the width is missing. And then I have a right angle, because thank you for doing that weird thing. Just kidding. Don't do that. All right, so we have a right triangle. So what I want to do is label once again. A and B are next to 90, and across is C. Okay. Now, even though we started with a picture, we can still do this using Pythagorean Theorem. So I'm going to do A squared plus B squared equals C squared. So I'm going to use W. W squared plus 8 squared equals 9.2 squared. Okay. When I do this, I am rounding my decimal to the hundredths, or otherwise known as 2 decimal points to the right of the decimal. Okay, so let's do some math. W squared equals W squared plus 8 squared is 64. 8 times 8. Now 9.2 squared. Let's find out. 9.2 squared. 84.64. Okay, so again, when I'm doing these type of problems, I'm going to have a decimal. So let's solve for W. Again, since I'm missing the leg W width, I'm going to subtract. Now, if you type that in your calculator, you're going to end up with 20.64. And then your last step is to square root. Now, hear me say this. You cannot find the square root of 20.64 using factor tree. It's already a decimal, and the instructions say get a decimal. So you got to type in 20.64 and actually hit enter and round it to the nearest hundredth, which is 2 to the right of the decimal point. So right here, this 3 makes this 4 stay the same. It's 4.54. And my units of measure are feet. Okay, 4.54 feet. I'm telling you, 2 of these are going to be decimals, so that's one of them. And then you have a baseball one, okay? Now it says a baseball diamond is square, okay? And it says it's 80 between each base, 80, 80, 80, 80. They want to know the shortest distance to the nearest tenth, which again is a decimal, 2 decimal points, between first and third base. Now, if you didn't know, this is first and this is third. Hopefully you knew that, but if not, you're going to connect these, okay? And don't you have a right triangle right here? Yes, you do. Okay, this is missing. Put an X there between first and third base. Okay, and now I can use Pythagorean Theorem because I see I make a right triangle with a missing side. Okay, so here's my right angle. I'm going to put A and B next to it, and across is going to be C. Cool. Let's set this up as Pythagorean. So A squared plus B squared equals C squared. 80 squared plus 80 squared equals X squared. Okay. What is 80 squared? 80 squared. 6,400 plus 6,400 equals X squared. Well, if I add both those up, I get 12800, otherwise known as 12,800. And my last step is to square root both sides. Don't do a massive factor tree when it tells you to get a decimal. Do the square root of 12,800. And I get 113.13, and that's 7, makes that 3, round up. So 113.14 feet. Okay, again, don't do a massive factor tree if it asks you for the decimal. Okay. Now, on the back, first one tells you to do simplified radical form. Again, simplified radical form is when you break down your square root. So let's break it down. 405 is not even. 2 is not going to work. Let's try 3. Is 405 divisible by 3? It is. 3 times 135. Okay, let's try 135. Let's try to divide that by 3. Hey, that works too. 3 times 45. And then 45, let's try that one. Divide that one by 3. 3 times 15. And let's try 15 divided by 3. We get 3 times 5. 5 is also prime. And that's our factor tree. Okay, so circle your pairs, cross one out, circle your pairs, cross one out. Remember, on your square root, the pairs go out and multiply, the loner stays in. So 3 times 3 on the outside is not 6, it's multiplied. 3 times 3 is 9. 5 loner stays in. 9 squared of 5. Cool. On number 6, when you're multiplying outside times the outside, 5 times 9 is 45. And then inside times the inside, 7 times 3 is 21. Even if you try to break it down, 3 and 7 are the only factors. So that's actually it. 45 square root 21. Now this next one's kind of tricky. Check it out. I have a square root of 5, a square root of 2, and a square root of 5. The only ones that I can combine are the square roots of 5. And if there's no number in front, please remember that's a 1 implied there. Write it if you need to. So I have a 7 square root of 5 plus a 1 square root of 5. What's 7 plus 1? 8 square root of 5. And then the leftovers, you need to just bring it down. Minus 2 square root of 2. Cool. That's it. On number 8, let's do another factor tree. 2 times 22. And 2 times 11. 1 pair of 2, 1 loner, 2 square root of 11. Because 11 is prime. On number 9, a square root times the same square root is just the number underneath. That's it, okay? Now you could multiply them and then try the factor tree. You're going to end up in the same spot. It's just 31, okay? Square root times the square root is that square root without the square root. Okay, last but not least, this one's kind of tricky. Remember, if there's a square root on the bottom, you can't have a square root on the bottom. So you multiply by the same square root. And if you do it on the bottom, you got to do it on the top. Okay? So times the square root of 2 on the bottom, times the square root of 2 on the top. On the top, a normal number times the square root, you just stick them next to each other. And then on the bottom, square root times the square root is the same number, just like we did on number 9. So it's just 2. Then you look at that 7 and that 2. Those don't reduce, so that's actually your answer. 7 square root of 2 over 2. Okay? So this is the review for your test. Your test is very similar to this, so make sure you can do Pythagorean and do these various square roots.